Today's class I am going to discuss you about phase shift oscillators. We'll see in detail. So already we have discussed about a transistor. Just we'll have a review on transistor. Then we'll see about oscillators. Then principle of oscillation, condition for oscillation, phase shift oscillator we'll see. What is oscillator? Introduction part. Oscillator is an electronic circuit that generates a periodic waveform on its output without an external signal source. And this oscillator converts DC into AC. Then oscillators are the circuit that produce a continuous signal of some type without the need of an input. So the signal of some type means it may be a sine wave, square wave or a shortwave wave. Then these oscillators are used in communication systems, digital systems like computers. What is oscillation? It is an effect that repeatedly and regularly fluctuates about the mean value. Then what is oscillator? A circuit that produces oscillation. Oscillator is nothing but it is a circuit that produces oscillation. Then we'll see oscillator in detail. As I told you earlier, an oscillator is a circuit that produces a repetitive signal from a DC voltage. It is used to convert DC into AC. See here, this is a DC supply voltage which is given to the oscillator. We will get the output, AC output. It may be a sine wave or it may be a square wave or it may be a shortwave wave. Types of oscillators. There are three types. One is RC oscillators, second one is LC oscillators, the third one is unijunction or relaxation oscillators. We'll see the types. RC, we have two. One is Wien's bridge oscillator, second one is phase shift oscillator. In LC, we have three. One is Hartley oscillator, Colpit oscillator, and crystal oscillator. And unijunction, there is no subdivision. So these are the types of oscillators. Let me repeat it. RC oscillators, LC oscillators, and unijunction bar relaxation oscillators. In RC we have two types, Wien's bridge and phase shift. LC we have three, Hartley, Colpit and crystal oscillators. Out of these, we'll see only the phase shift oscillator today. RC means it's a combinations of resistance and capacitance network. LC means it is a combinations of inductance and capacitance network. This is the basic principle of oscillation circuit. It consists of a non-inverting amplifier and a feedback circuit. AV is a voltage gain. So this is V0 is a output. Here the output is given to the feedback circuit. Then VF is a feedback voltage. We'll see in detail. When the feedback voltage is given to the non-inverting amplifier, it won't invert the signal, but the amplitude will be getting increased. That is, it amplify the signal. Then the amplified output should be given to the feedback circuit. So here the amplitude will be getting decreased and we'll get a feedback voltage. So that means the feedback voltage and the output voltage are in phase. This is the basic and fundamental principle of oscillation. Next we'll see the condition for oscillation. The condition for oscillation is called Barghasan criterion. See the same diagram I have given in different way. This is the amplifier with gain A and this is a feedback network. Here EG is the input voltage and here the input voltage should be given through the amplifier before feedback. So before feedback the output will be E0, then E0 should be given through the feedback network, then output will be beta into E0 and this feedback voltage should be given as an input and this is after feedback. We'll see the conditions. So here A is the voltage gain of the amplifier without feedback and EG is the input voltage, E0 is the output voltage. So before the feedback, the total output voltage is EG plus beta into E0. Then after feedback, the equation will be EG plus beta into E0 into A is equal to E0. So from this we can calculate EG value. So then we can say that A beta is called a feedback factor or a loop gain. The condition A beta is equal to 1, that is called the condition for oscillation. or we can say that it is a Barghasan condition. So from this, beta is equal to 1 by A. What we are concluding from this? The magnitude of the product AB should be unity. That is, A beta is equal to 1. The product of the phase angle of 2 should be 0, or it is the integral multiple of 2 pi. So next I'll move to phase shift oscillator. We'll see the circuit first. Then this is a phase shift oscillator. This is NPN transistor RECE, or the emitter resistance and emitter capacitance. And this is the RC network. R1, R2 gives the potential divider for the base. So here RC is nothing but RC, or RL is a load resistance. VCC is a power supply. And this is a single phase RC network. That means single phase means it consists of only one or one C, and VI is the input and V0 is the output. And this is a three phase RC network, that is RC, 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 VI is the input and V0 is the output. We'll see the working in the next slide. So once again, RC phase shift network is a simple resistor capacitor network that can be used to give the desired phase shift to a signal. This is a single stage RC phase shift network. It has only one stage. One R and one C. This is the input output. So here the phase angle is equal to theta degree, 0 degree, and here the phase angle is equal to 90 degree. And F is the operating frequency, R is the resistance, and C is the capacitance. So then the capacitive reactance is given by XC. XC is equal to 1 divided by 2 pi F into C. Then the effective impedance is Z, and Z is equal to root of R squared plus XC squared. Then the phase angle is given by pi, which is equal to tan inverse of XC divided by R. Next we'll see the three stages of phase shift oscillator. What will happen when we connect the three-stage RC network? So one stage, the angle is 60 degree. That is, phase shift is equal to 60 degree. Then the second stage, it is 120. Third, it is 180 degree. So totally, the phase shift produce 180 degree. And the transistor we'll be using in phase shift oscillator, that also produce 180 degree. So totally, the total phase shift will be 360 degree between input and output. Then we'll see the three-stage RC coupled phase shift oscillator. So here RC, 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 this is a three-stage RC phase shift oscillator. See here, the phase angle is theta degree. Then after the first stage, the phase angle is 60 degree. Then the second stage is 120 degree. And finally 180 degree. See here, this is the input wave and this is the output wave. Here the phase is getting shifted. And this circuit gives the three-stage RC phase shift oscillator. Q1 is a transistor, NPN transistor. So this is a three-stage RC network. It produces 60 degree and the second 120 and third totally 180 degree. RE is the emitter resistance, CE is the emitter capacitance. Cout is the output resistance, RC is the collector resistance, R1, R gives the potential biasing for the base. VCC is the power supply. What we can understand from the diagram. So the R1R gives the voltage divider bias to the transistor Q1. Then RC is the RC is the collector resistance which limits the collector current. Whereas RE mean for thermal stability. CE is the emitter bypass capacitor and Cout is the output DC decoupling capacitor. Suppose instead of three phase shift stages, we can move with one more stage, 4 stage. Then the angle will be get reduced 4 into 45. So this is for more stability. We can use 4 stage. Instead of 3 stage, we can go with 4 stage. So that means the stability of the oscillator can be further improved. Then the frequency is given by the formula 1 divided by 2 pi RC root of 2n. So R is the resistance and C is the capacitance. N is the number of RC phase shift stages. Suppose if you are using 2 stage means we have to substitute 2 here. Suppose if you are using 3 means we have to use 3. Similarly, if you are using 4 means we have to substitute 4 here. So with this I want to stop this phase shift oscillator. The next things we'll see in the next class. Thank you, students.